Around the turn of the 21st century, a whole new era of space exploration began. Exoplanets are planets that are not in our solar system. Astronomers have only recently been able to see them because telescope technology has improved on both Earth and in space. Astronomers have confirmed the existence of about 4,480 exoplanets in our galaxy, the Milky Way, and found many more that could be there. There is a chance that some of them are rocky. Many of them are in a group of planets called super-Earths, which are spheres that are 2 to 10 times as big as our home. Others, like Jupiter, are huge gas giants that are the biggest in the group. It's possible that there are more than 1 trillion exoplanets in our galaxy alone. We only know a very small amount about them, though. "We've barely scratched the surface," said Nestor Espinosa, an exoplanet researcher at the Space Telescope Science Institute, which runs the James Webb Space Telescope, or JWST, which was just launched. The James Webb Space Telescope is run by the Space Telescope Science Institute, where Espinosa works. "We've only scratched the surface to a very small extent. The much-anticipated telescope will take pictures of some of the most remote parts of space, where the first galaxies formed that have never been seen before. But the powerful space telescope will also spend a lot of time, a quarter of its first year and probably more time after that, looking at exoplanets in our own Milky Way galaxy." Spectrometers are specialized pieces of equipment that the JWST has, and they'll completely change what we know about these faraway worlds. We'll find out if the atmospheres of these planets, which are located trillions of miles away from us, have things like water, carbon dioxide, and methane, which are needed for life as we know it to grow. Even though we don't expect the instruments to send back stunning images of planets outside of our solar system, we do expect them to send back a lot of information about worlds that we can only imagine right now. Seeing things that are impossible. A large number of planets outside of our solar system are super-Earths. For example, the extrasolar planet Kepler 186f is about the same size as Earth and circles its star in a place where liquid water could flow on its surface, called the habitable zone. But planetary scientists think that other super-Earths are harsh places to live. K2-131b is one example. Its orbit is so close to its star that it can evaporate metal. Astronomers have found more than 1,500 of these super-Earths, which are very different from each other, but we still don't know who they are. Is there even one that looks even a little bit like Earth? We don't know anything about them, not even if they have atmospheres or not. Espinosa said, "Webb will make it possible for us to find these things. We'll find out if any of these planets have the same amount of carbon dioxide and water as Earth." He said it was a really big place. Webb will look at the exoplanets that have already been found instead of wasting valuable telescope time looking for new ones. Most of these extrasolar planets were found by Kepler, which is a very good telescope for finding planets. Kepler spent almost 10 years carefully looking at stars in small areas of space, looking for changes in how bright they were. Most of the time, these drops happened when planets crossed in front of their own stars. Even the powerful JWST, which has a gold-colored mirror that is more than 7 meters wide, will only see these faraway super-Earths as dots. But we can still learn a lot from the telescope about the atmospheres of these worlds. Astronomers will use a clever plan to see things that can't usually be seen. They'll wait until the planets move out of the way of the bright stars they control. This starlight goes through the atmosphere of the exoplanet, then through space, and finally into spectrographs on top of the James Webb Space Telescope, a strategy called transit spectroscopy. They work a lot like high-tech prisms in that they split the light into a wide range of colors. Here's the most important secret. There are molecules in the air that, like water, can take in different wavelengths or colors of light. Espinosa said that each molecule has a different diet. To explain this, so if that color doesn't show up in the spectrum of colors that a Webb spectrograph records, it means that the atmosphere of the extrasolar planet absorbed or ate it. In other words, tiny amounts of that element are found in the air of that planet. The spectrograph doesn't make pretty pictures, just lines that show the different kinds of light being measured. However, the information it gives is very useful. Mercedes Lopez Morales, an exoplanet researcher and astrophysicist at the Center for Astrophysics, Harvard and Smithsonian, says, "We're going to be able to tell what the planets are made of." The Center for Astrophysics at Harvard and the Smithsonian made this claim. Lopez Morales is part of a team that's studying the atmospheres of exoplanets by looking at what Webb will see in the future. She said that the main way spectrometers get information about atmospheres is through a process called transit spectroscopy. The spectrometers will also gather information about different atmospheres in other ways. When Webb launched in 2018, It was able to take direct pictures of Neptune and other big planets that are farther away from their stars. Large planets, which are often young, hot and made of gas, give off a lot more light than smaller planets. This is infrared light, which you can't see with your eyes, but Webb can see it, and there are enough of them for him to be able to figure out what it says from trillions of miles away. Is there life somewhere else? Webb will tell us if our solar system is strange or not compared to other ones. Another possibility is that it will only tell us whether or not a normal exists. There are many things to ask. What are most solar systems like? Is it rare to find a planet like Earth that is full of water and orbits in a nice zone where people can live? Do other gas giants like Jupiter and Saturn have atmospheres that are similar to those of Jupiter and Saturn? Lopez Morales says, Webb will let us put our solar system in its proper place for the first time, but this won't tell us if there is life on a planet or not. Even if a planet has everything needed for life, even the most powerful space telescope ever built wouldn't be able to find it. Does it have life or does it not? It's really hard to answer that question, stressed Espinosa. Habitability is a complicated idea because it depends on a lot of different things. It is possible for a planet's atmosphere to get thicker and thicker over time, like Venus. This would make it impossible for life to live on the planet's surface. It's also possible for a planet to have a lot of water, but its climate could be controlled by strong ice ages, making it hard for creatures to live and grow there. This is all important information. Lopez Morales says that you need a lot of information before you can say that another planet is similar to Earth. But the most important thing is that Webb's observations will point scientists who study exoplanets in the right direction. Lopez Morales says that this brings us to the next level. A planet with conditions and parts that are about the same as those on Earth would be a scientific gold mine. She said that more research into such a world would be a high-priority candidate right away. The intriguing leads found by the Webb Space Telescope could then be followed by even more advanced observatories, which could be sent into space in the 2030s and be used to learn more about exoplanets that are like Earth. But it's important to keep in mind that as humans look into the possibility of life on exoplanets in the warmest parts of other solar systems, we might miss other places where life could grow by accident. In our own solar system, scientists are getting very excited about the idea that there might be life in a presumed salty sea on Jupiter's moon Europa, which is very far away. It's possible that Enceladus, one of Saturn's moons, also has an ocean under its icy surface. Jason Steffen, an assistant professor of physics at the University of Nevada, Las Vegas, who studies exoplanets, says these places where we think life could exist are all outside the habitable zone. If we only look for places where a world like Earth might exist, we might miss something. Still, the JWST will show people for the first time what is out there, moving around other stars in the universe. Even though it won't be a literal picture, who knows what we could find? Thanks for watching this video.